end behavior. So we've been talking about limits and continuity, and that's if our values are approaching a specific value, which we've been calling C. But what about the ends of the graphs? So the ends of the graphs, there's left end behavior and right end behavior. Okay, so left end behavior is what's happening when the x values are approaching negative infinity. So as our x values are going to the left, what's happening to the y? And we write this in limit notation. So the limit as x approaches negative infinity of the function is approaching what? And then right is as x values are getting bigger, they're going to infinity. So it's the limit as x approaches positive infinity of f of x equals. So to determine this, we're going to be using tables. When you use your table, you're going to have x values and y values. And then I'm only going to require that you have 7 different values, but you can do more. So I think that's 7. So you're going to start with your value of 0 right in the middle of the graph. And then we want to know as x is approaching infinity, so we want to get bigger. So you 10, 100, and 1000. If you want, you can keep going just to double check, but I only need you to do 3. And we're getting bigger so significantly. As opposed to with continuity, we're getting really close to the number. Here we want to go far away because we want to make sure we're getting big enough going towards infinity. So over here, same idea, but we want to know left end behavior, so going towards negative infinity. So that's going to be negative 10, negative 100, negative 1000. Oops. And then you're going to substitute these into your f of x equation and figure out the y values and determine what's happening. This is going to drive me crazy. Okay. So let's do an example. So find the end behavior of g of x equals x cubed minus 9x plus 2. And we want you to be showing this algebraically. We basically want you to prove it using a table. So we're going to make a table, x and g of x. I'm going to give myself 3 spots for each. 1, 2, 3, 4, 5, 6, 7. Okay. And in my table, I'm going to have center value of 0. And I'm going to get bigger, so 10, 100, 1000. Smaller, negative 10, negative 100, negative 1000. So to figure out your y values, you can do one of two things. You could either substitute it in for each number, or you could graph it and use the trace feature, which I personally like to do. I'm going to use my TI Nspire. So I'm on my coordinate plane. I'm going to graph a new function. So x cubed minus 9x plus 2. Oops, that didn't work. Let's try that again. It does have a graph. My axis is currently non-existent. Okay, x cubed minus 9x plus 2. Okay, so it's graphed. You can't see it, so I'm going to change the window. Window settings. I'm going to change it to just a 10 by 10 and see what that gives me. Okay, so now I can kind of see more of my graph, and you can kind of, honestly, you could write a statement based off just the graph. So these are going up, it's going to go to positive infinity and negative infinity, right? But I still want you to confirm with the table. So now I'm going to trace, and at 0 we're at 2. So now I'm going to fill in my table. So here we're at 2. 10 we're at 912. Here we're at 999,102. And here we're getting scientific notation. So my calculator is saying, here I'll write it in a different color. My calculator is saying 1E12. What this means is 1 times 10 to the 12th power. Right, so that means we're going to have 10 zeros to the right. So it's a really, 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 really big number. So negative 908, negative 999,098, and then I got scientific notation here again because it's such a big number. Well, in this case, small. So the next required piece, I've got my table. I want you to look at it and make a conclusion. So as my x values are going towards positive infinity, my y values are going towards, well, they're getting huge, so they're going towards positive infinity. And on the left, as we go down towards negative infinity, because this is end behavior, so we're going to the outside, my values are going towards negative infinity. And you can confirm this using a graphing calculator, right? We're going up and down. So now all that's left is to write it in limit notation. So they're going in two different directions. So the limit as x approaches positive infinity of g of x. So as my x values get huge, my y values get huge. So we're going towards infinity. And then as my x values are going towards negative infinity, we're going towards negative infinity. And then we're done this problem. So, do you have a table? Do you fill in your table? Do you have arrows? Do you have limit statements? If you answered yes to all those questions, then you are good and you're done this problem. And next example. Do one more. Find the end behavior of f of x equals 3x squared plus 5 over 2x squared minus 1. So, let's make a table. This function's f of x. I really should count as I go, huh? Okay. Because it's end behavior, it needs to get bigger and smaller to the right and left. So 10, 100, 1000. Negative 10, negative 100, negative 1000. Okay. And this should look familiar. You guys did this in Algebra 1, and we're going to be doing these again in the near future. But anyways, so if we look at this graph, right, as x is going off to positive infinity, it's actually flattening out. Right? It looks like it's approaching a number, and then to the left it looks like it's also approaching a number. It's not going down infinitely. Here it is, but remember it's as x's are getting bigger. So I'm going to use the trace feature and figure out my corresponding y values. Okay, so at 0 we're at negative 5. At 10 I've got 1.532. and you can use decimals here. I think it's going to make it more accurate. For 100, I'm getting 1.500, and then there's some more numbers, but we don't need to write the whole thing. For 1,000, I'm at 1.5. Negative 10, I'm at positive 1.532. 1.500, and then a little bit more, and then this one is actually just 1.5. So now, again, as x is going towards positive infinity and negative infinity, what is happening? So it looks like it's going to 1.5. If you're not sure, this is where you could enter more numbers. So even though it's at 1.5, I could do 10,000. Did I do too many zeros? I did 100,000, right? And it's still going towards 1.5. So it's safe to say that our x values are going towards 1.5 on both sides. Now, because it's going in the same direction, they're both going to 1.5, you can just write one limit statement if you like. So the limit as x approaches plus and minus infinity, so as it's going to both, our y values, f of x, are approaching 1.5. And that's it. So you can, your end behavior can be going off to negative infinity and positive. It could be both going up to positive or both going down to negative. Or it could be approaching a number. So that is it.